Good afternoon. We conducted the security testing on our Stack web application for a mobile shop using both manual testing and tools like SonarCube and SAP. Through this, we identified several vulnerabilities, including NoSQL injection, denial of service attacks, insecure direct object references, and cross-site scripting. We also found issues with our cost policy, which could expose the application to unauthorized access. To enhance security, we are addressing these vulnerabilities and have securely integrated Facebook login. This will help protect our system and user data effectively. Uh, One of the fixed vulnerabilities is cross-site scripting. Uh, it is a security issue that happens when attackers insert harmful script into web pages that other users see. This can other users see uh, like this input validation is sanitized. You can see that in the code, and this can lead to unauthorized action and stealing information or even talking or accounts. To prevent uh, cross-site scripting, we made sure to validate and clean any input from users to that only safe data gets displayed on our website. We also set up a content security policy that limits where scripts can come from, adding an extra layer of protection for our application. Another one is fix is denial of service via uncontrolled resource consumption. That is, this is occurs when too many requests flood are come into the application, making it unavailable to real users. Like that, if a user upload large file and getting CPU power is more high and going down the server, like that. To tackle this problem, we improved our API by adding rate limit. And you can see the code, uh, which restrict how many requests a user can make in a certain time. We also made sure that tasks that use a lot of resources are managed properly and stop when they are no longer needed. Uh, and also, I implemented the how to integrate Facebook login into our web application, streamline the user authentication process. This approach allows users to log in quickly and securely using the existing Facebook accounts, eliminating the need for them to create and remember new credential. By leveraging or we enhance user experience while ensuring data security, as we only request necessary permissions and adhere to privacy best practices. This not only simplifies registration but also align our application with modern security standards, making it more user friendly and robust. Uh, this is how implement the Facebook login. React has default library for Facebook login and can this is a PID section. Uh, this is my part, and I invited to Sabri to continue.
Thank you, Malit. So my question is NoSQL injection prevention. The application was vulnerable to NoSQL injection attacks due to unvalidated user inputs being directly passed into the database query, allowing attackers to inject malicious commands. So to prevent this, input validation has been added to prevent NoSQL injection. Specifically, the login route now checks if the input is of the correct type, string, before querying the database. This ensures that only valid strings are used in the query, blocking any NoSQL injection attempts. And next one is denial of service attack via excessive request flooding. Denial of service attack can occur when an attacker sends an overwhelming number of requests to the server in a short period of time. This type of attack, known as request flooding, can degrade the server's performance or cause it to become unresponsive by enhancing resources like CPU, memory, or bandwidth. So to prevent this attack, a rate limiting mechanism can be applied, restricting the number of requests a client can send within a specific time frame. If the limit is exceeded, subsequent requests from the same client are blocked for a set duration. So in here, the solution we have implemented uses a rate limiting middleware from Express to protect the application from excessive request flooding by setting a limit of 100 requests per IP address with a 15-minute window. The server can prevent potential attacker from overwhelming the application with repeated requests. If the limit is reached, the client will be temporarily blocked. So thank you. That's all. Next, I will invite Mindali to continue.
Thank you, Sabri. I'm WRM Vikram Singha, and the first vulnerability I'm going to address is insecure direct object reference. This occurs when an application exposes a reference to an internal implementation object, such as a file or a database record, without proper authorization checks. An attacker can manipulate this reference to access unauthorized data. So as a solution, I have implemented a protected route component in React, which uses JWT and the which uses a JWT token and the role in the token payload to check if the user has admin privileges before granting access to certain routes. Then I have added this component to the specific routes, like the admin dashboard. And I have also added backend route protection where the token is verified and the user role is checked before serving protected resources. And the second vulnerability I'm gonna address is exposure of sensitive data in version control. If sensitive data like MongoDB connection string or JWT secret key is hard coded and you push your code to version control system, it becomes available to anyone who accesses the repo. If the repo is public, attackers can easily exploit this information. So I have migrated this risk by moving sensitive data like PB URL, secret key, and port to environment variable stored in .env file and access those access those by that file. So this will separate configuration from code and prevent accidental exposure. Thank you, and I invite Yapa to continue.
Thank you, Minduli. So my first vulnerability is gonna premises cross origin resource sharing policy. So CORS is a browser security feature that restricts the web application from making requests to the different domain than the one that served the web page. So by default, the same origin policy blocks cross-origin requests to the protect against attack, so such as CSRF or cross-site scripting. So likewise, however, having a permissive ghost policy can expose your web application to security risk. So in this code, this code part, you can see after fix the issue that including the middleware with restricted origin and define the trusted origin for cross policy. And also another significant vulnerability is DDoS attack, so regular expression denial of service, so that exploit the about the regular expressions. So when poorly designed regular expressions are used in input validation, especially with nested quantifiers, so likewise, so it will gonna be a long time process, and attackers can use the vulnerability to because program using regular expression to hang for a very long time. So so in this code part, uh, I commented that. So in this code part, you can see the email validation with the regular expression, regression expression. So therefore, it occurs complexity of regrets and also lack of import invitation. So that is why this code is vulnerable. So after that, this is code shows the that vulnerability is solved part. So you can see we add the validator library so for solve that. So it is pre-optimized function and also no regress complexity. um, so likewise, so by migrating from manual regress to a well-tested library like validator, yeah, our email validation process become not only more reliable but also significantly more secure against DDoS attacks. So that's all. Thank you.